today we're going to do some probability. Now, one of the things I always say as we're doing combinations that you guys probably remember if you've been here before is that probability and combinations are very related. Now, this is something that I would tell you I wasn't quite aware of when I first started doing probability many, many years ago with the GMAT, or even probability back in the day. Once that clicks, life's pretty good, because then what's happening is you have one set of skills that work for two different problem types. So I guess that's a question I'll ask you guys just to ask. Are you guys aware that combinations work well with probability questions? I mean, I'm guessing you guys, if you're using TTP or you ever worked with me or been to any of these, I'm sure you know this. But I'm just curious, like if anyone's new to it, maybe you don't. Oh, you were not? Okay, perfect. Now look, if you guys haven't done combinations, and this is going to be a little bit challenging for you, so I would say get into the TTP course and look through these chapters, because they're, they are chock full of this information, but obviously we're not going to lead our way up. We're just going to jump into some of these questions. So I'm going to start off with a pretty basic one where you can blatantly use combinations for the favorable and total outcomes. And I just want to show you guys how to know that these two things relate. So let me just get this open and okay, give you guys a few minutes and then you can go from there. And put your answer in the chat box. All right, so cool. Everyone pretty much got this correct. Did you guys use combinations here? Obviously, that's what I was leading you into doing, just making sure that's what you actually did. Yes, yes, yes. Okay. Now, let me ask you guys another important question. could you guys tell? Okay, so not using combinations didn't get you the right answer. So that's a good thing because combinations are a really, really great way to deal with this question. But let me ask you something else here. Does this look like a combination question to you guys? Like, all right, if we just removed what is the probability and we said, I'll remove that in a second. How many ways can three cats and two dogs be selected? Does that guy remind you of a combination? Like combination question? Yeah, exactly. So one of the things to keep in mind is that if it looks like a combination and walks like a combination, it can be solved using combinations. The only difference is we're talking about favorable outcomes over total outcomes. Remember, if this was just a combination question, the favorable outcomes would be the answer. But instead, it's probability, so you put it over the total outcomes. Now, what are the favorable outcomes? Well, there's 5 cats. We need 3 of them. That's 5, choose 3. There's 2 dogs. There's 3 dogs. We need 2 of them. That's 3, choose 2. Total outcomes, there's 8 total animals. We need 5 of them. It's over 8, choose 5. And then we just do our normal steps here. 5 times 4 times 3 over 3 times 2. We get 10. 3, choose 2. We just know it's just 3, so that's easy enough. 8, choose 5. 8 times 7 times 6 times 5 times 4. We get 1, 2, 3, 4, 5, and then divide by 5 factorial. 5 times 4 times 3 times 2. These cancel. It cancels. You may end up getting 56. That can reduce down to 15 over 28. Now, for the people that didn't use combinations here, I'm not going to get into why your method doesn't work other than saying you have to account for multiple outcomes. It's something we do in coin questions or independent probability questions. It's an added step, but in those questions, you can't really use combinations. You have to do it. In this particular case, because combinations are an option, there's no point in not using them. So practice this method and practice getting good at it, because telling you it's going to save you a lot of time on the test and it's going to save you a lot of accuracy. So just keep that in mind, moving forward. If you're new to this topic, it's fine. You'll eventually learn it. You definitely have to do combinations first, though. All right, try this one here. Now, is it safe to say everyone used combinations here, even though you didn't use them last time? All right, well, let's assume you guys did. Yeah, same process here. 4 even numbered. I mean, same thing as cats and dogs, right? 7 odd numbers. Giselle's taking 4 cards overall, right? So that's going to be the total outcomes is going to be 11, choose 4. Now remember, as you get good at this, you don't have to like write out favorable total equals, like you'll know what all that means. 2 even, 2 odd, 4C2 times 7C2. So the favorable isn't bad. Isn't bad. 4 times 3 divided by 2. That's 6. 7 times 6 divided by 2 or 2 factorial, same thing, times 21. I'm not going to multiply 6 by 21 because chances are we're going to reduce. Then 11 choose 4. 11 times 10 times 9 times 8 divided by 4 times 3 times 2. 4 and 2 reduces the 8. 3 goes into 9 3 times. So now we have 11 times 10 times 3. Again, I didn't even bother doing the math out quite yet. These things will reduce. 3 goes into this 7 times. 2 goes into this 3 times. 2 into this 5 times. And you can see 21 over 55 is our answer. All right. So it sounds like you guys are pretty good with those. Now I want to go through some variations of these, just like there's variations and combinations and permutations. And, you know, if we have time, maybe we'll do like one multiple outcome problem so you guys can see the difference on like here. It's a good one here. All right, take a stab at this here. All right, so I think we got a bunch of correct answers here. So this is just a variation, right? So we have 9 chips total, and we're selecting 4. So we know right away it's 9 choose 4 in the denominator. Now, what's the probability that none of the black chips are selected? Okay, there's 3 black chips. We know there's 9 total chips. So we take them out of the running. So there's now 6 chips we can choose from, and we're getting 4. So it's 6 choose 4 over 9 choose 4. So we do that out. That's going to be 6 times 5 times 4 times 3. That's going to be 4 times 3 times 2. So that goes away. That becomes 15 in the numerator. And then 9 choose 4, 9 times 8 times 7 times 6 over 4 times 3 times 2. 3 times 2 is 6. 4 goes into 8 twice. So we have 9. I'll answer that in a second. And you can't, because none of you're thinking of an at least problem, but I want to just say something really important in a second. So we end up getting 5 here. That's a 3. And then it becomes 5 to 42. Okay. No, you can't do, I don't want to get into it too much. The answer is no, you can't do it. We have a whole lesson dedicated to that. It's not a mutually exclusive event. But here's the more important thing. I have a really serious question for you, because I ask students this all the time. Why would you take a problem that's super simple and try to get so cute with it for no reason at all? It's not like what I did was hard. Now, if this was an at least one question where you would have to do out 3 scenarios, okay, fine. Yeah, do the mutually exclusive events, the 1 minus and all that stuff. But like, why take something that's super simple and try to make it harder, right? If this was a scenario-based question where you're avoiding having to do 3 scenarios, I totally agree. But do not, under any circumstance, get so cute with a problem that you're taking something that's simple, and not only are you making it harder, you're then getting it wrong. So I want you to be really careful about that. Put things like this on flashcards. You don't do it, and it'll be fun. What difficulty level? I mean, it's tough because it's relative. If you don't know probability, I still wouldn't do it that way either, because then you got to account for multiple outcomes. But you can if you want. I prefer combinations over any other method, unless it's a multiple outcome question. The difficulty is, I don't know, medium to hard. I mean, if you know nothing about probability, you're not getting this question right. Problem is not the problem. The good news is if you know about combinations and you do this, then it's actually pretty damn simple. So it's really hard for me to say sometimes, because it kind of depends, whose eyeballs are on the question and what their experience is with these types of questions. All right. I want to do, one more here, and then maybe we'll do a couple multiple outcome questions, and I can even show you in at least one question to kind of close the loop on that. So do this here, and then we'll discuss. get out, 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 get out. All right. Looks like you guys were good here. 9 snowboards, including Roberto and Jose. 4 people are selected. Okay, so that's 9C4 on the bottom. Although Roberto is selected, Jose is not. So we've accounted for 2 of the people, right? So the list comes down to 7. And we still need to select 3 people because Roberto is selected. So 7 times 6 times 5 over 3 times 2. That's going to give us 35 here. And then 9C4 is 9 times 8 times 7 times 6 divided by 4 times 3 times 2. So we have 35 over 9 times 2 times 7. So 7 goes into that, of course, 5 times. And then we have 5 over 18 as our answer. That's it. Okay. I want to do 2 more real quick, multiple outcome problems, and we can do some Q&A. Give me a sec here. So for the person who I was talking about having to deal with multiple outcomes, I'm sure some of you guys already know it, but I just want to show everyone here so you can see why sometimes we absolutely have to use straight probability with multiple outcomes. Just gotta find the questions. Here we go. Yeah, so something like this. All right, try this here. Okay. So the difference here, looks like you guys got this right. You do the probability out. First and foremost, it's 1/2 regardless. So it's going to be 1/2 to the 4th. The answer, of course, isn't 1/16, which is the trap answer. You have to account for the multiple outcomes. So we're talking 2 heads, 2 tails. That's 4 factorial over 2 factorial times 2 factorial. That's 4 times 3 times 2 over 4. So that's 6. So it's 6/16 because you're multiplying, which is equivalent to 3/8. So what you're doing is you're taking the different ways you could get an H and H, a T and a T. You're using that fun permutation thing that we do. You're calculating it, permutation of indistinguishable events. And then, you're going from there and you're multiplying, getting the answer. So it's not anything crazy. It's just something different. It's something I'd prefer not to do if I don't have to. Now, the last question before we do a little bit of Q&A is the one where I said we would show an at least type problem. And that is where you can actually save time and save time appropriately. So that's this here. All right. So how did you guys feel about this one? I mean, it looked like most of you guys got it right. Did you try to do the 1 minus when solving this? Hoping that is how you did it. All right, perfect. So yeah, so this is the time you do it. Pick at least one red marble, but how about no red marble? So there's 10, 20 total marbles. There's 10 blue, 5 yellow. So if we're talking about no red, it's 15 over 20, which is equal to 5 over 4, or excuse me, 3 over 4. No, sorry. 5 goes into 15 3 times. Yes, 3 over 4. You're doing that 3 times because you're getting no reds with 3 choices. So you end up getting 27 over 81, and then you just subtract that from 1, like you guys did, and then that's how you get, not over 81, over 64. I don't know why I said 81. And then you subtract that, and you get 37 over 64. That's a good time to use it. So that is it. I think we covered some good stuff today. Does anyone have any questions as we wrap this up? Any questions about your prep or anything like that at all? Anything about TTP, whatever it is. Let's see here. If we use the converse, we actually teach this in depth in our course. You should check it out. It's a lot to talk about here. But yeah, I just mean other questions, non-content related questions. Once you see it, it'll be very clear. Yeah. Don't worry about it then. You'll get it. This is just a nice little game for you. But yeah, does anyone have any other questions? Let's see. Casing of note taking. Well, you just have to take notes in the stuff that you deem important, where it allows you to just put things in your own words. You know what I mean? The other thing too is if you feel like you're advanced past a certain topic, when you get to it in a chapter lesson, you just skim it and move on. So the real key is that you're just doing the stuff that's of the utmost importance to you. I think that's going to help you get through the course as efficiently as possible, if that makes sense. Any other questions? We do not have a time for that. Yeah, that's good advice. I mean, listen, a lot of times notes is just to make sure you're paying attention while you're going through this stuff, right? There's a lot that you're doing. So yeah, you just have to, it just keeps you on point. Imagine watching a whole video, not taking a single note, and then asking yourself if you followed it completely. That's why we take notes when, we're reading comp passage. It doesn't mean we're going to necessarily go back to those notes. It's just ensuring that, we're understanding what we're reading. All right. Any other questions? All right. Well, if that's it, everybody, have a good weekend. Thank you for attending, and I will talk to everybody next week. Take it easy, everybody.